Hello everyone, let's start solving today's Leetcode daily challenge question. I recorded this video. This is the second time I'm recording. I already recorded, and after at the end, I got to know that I shared a wrong script. Okay, now let's solve this question. So find the punishment number of an integer. So given an positive integer n, return the punishment number of n. The punishment number of n is defined as the sum of the squares of all the integers I, such that 1 less than or equal to I less than or equal to n, and the decimal representation of I into n can be partitioned into contiguous substring, such that the sum of integer values of this substring equals to I. So we are given with the n integer, which is a positive integer. Okay, and we have to return the punishment number of n. What is the punishment number of n? It is the sum of all the squares of sum of squares of all the integers I, where I belongs to from 1 to n, where the where I, okay, I should be equal to part partition of I into I. Okay, sum, basically sum of partition of this. So for example, if my I is 9, what is the square of 9 is 81, and if I do the partition 8 and 1, what is the sum is 9. So this is what this I is equal to partition of sum of partitions of this square. So 9. So these numbers, this these mean like whatever the numbers will get from this 1 to n, that is I, we have to add it in the punishment number, and we have to return that punishment number. Okay, so if we see this example, let's see the example where n is equal to 10. Okay, if my n is equal to 10, we have to do from what, 1 to 10. So let's find the square of 1 is 1. Okay, square of 1 into 1 is 1. Okay, I'll write only 1, and the partition we can make 1. Square of 2 is 4, and its partition is only 4. Square of 3 is 9, and its partition is also 9. Square of 4 is 16. What is its partition? We'll get 1 and 6, so 7. Square of 5 is 25. The partition we can make only is 2 and 5, which is the sum is 7. Square of 6 is 36. As these are the two digit numbers, okay, the squares are two digit numbers, so we can make only one partition, that is in between 3 and 6. So here 3 plus 6 will get a 9. And if I do the square of 7, we will get 49. The square and the sum is 13. And this 8, if we do the square, 64, and the is will be 12. And if I do the square of 9 is 81, we can make only one partition, 8 and 1, and the sum is 9. And if I do 10, the square of 10 is 100. Here I can make two partitions, either here or here. Okay, so if I make here, I'll get 10 plus 0, which is 0, 10. And if I make here, so what I'll get, 1 plus this 0, which will get 1. So we will consider this. Okay, so why? Because my this partition, sum of this partition is equal sum of partition is equal to the number. So similarly here 1 also, sum of this is same, and for 9 also these two are same. So only 3 are there, and we have to return what, sum of its square. Okay, that means 9 plus 100 plus 1, 981 plus 100 plus 1, that means 182 is our answer. So here you can see 182. So for 37, here it was what, here it was only two digit, so we can make only one partition. Okay, I mean two partition we can make, but only one cut we can make. So if we have three digit number, we can make two cuts. Let's say here you can see two cuts I made, right, here and here. But if we have four, then we can make three cuts different. Okay, so let's see this example. N is 37 and 1436, and in that we know 1 9 and 10 is there. For 36, for this we will check. So I will use a paint to show you how we can solve this question. Is what is our n? N is from 1 to 37, but my current I is 36. Okay, what its square? Square, you can say square. We'll write square only. What is it? Square 1296. 1296. Okay, this is my square and this is my I. What I need to do is I have to make partitions of this such that its sum of the all the partitions should be equal to 36. So how many I can do the partition is, let's say here we have this 1296. Okay, so let me move this. Okay, now fine. How many cuts I can do? Either here, here, or here. Okay, so let me use this. We can make how many? Three. Is one will be like, I'll write this. Okay, so like this. What will be here? Add. Let me complete just, yeah. So here it will be one. Let's say I'm doing the partition from the beginning, or we can make it at the end. So from the end also we can do, let's say 129 and what is 6. This is my one partition. Again, if I do this here, okay, so it will be 12 and 96. Okay, and here it will be 1 and 296. So this is the three cuts I made in the initial. So what is the sum of these two? Is 129 plus 6 is 134, right? 135. And what is the sum of these two? Or let's say what we will do, control Z I'll do. Oh, okay. So instead what we can do, instead of finding the sum, we can subtract this 36. If I do subtract 36 minus 6, what I'll get? 30. Okay, so here I'll write, here I'll use different color. So here my 30 is remaining. Why? So this 6 we considered in our partition, and 129 we can do again partitions. So this is 30, and if I have to divide this in I have to do cuts in this such that the sum of these two will be equal to 30. Okay, so if I make here 96 minus 36 minus 96 will be minus 60, which will be our invalid case. Okay, and here also this will be our invalid case, as 36 minus 296 will be what? Minus 260. So this will be my, these two will be my invalid cases. Okay, so here what, how we can do is, again we can partition this into what? We have two choices. Is one is like this. Okay, 1 and 29, or we can make 12 and 9. Okay, so what is the sum of instead of sum, what we will do is 30 minus 29 is what? 1. Here is 1. Okay, what happened? Is 1. Okay, and again 30 minus 9 is 21. Now I have to make partition of this such that the if my both this is my target, consider this is my here I'll write 36. Okay, so this is my target and this is my num. If my target and num are same, that means this two I got same, right? So I can say this path means 1 plus 29 plus 6 is what I get 36. 1 plus 29 plus 6 I get 36, so that I can add this number in our punishment number. And if my this number, that means this, I cannot make this negative number, right? This negative number, that means this 96 cannot be our partition, so I am getting negative. So this is one invalid case, this is one invalid case. And again here also my target is 21. I want 21 more after this reducing 6 and 9. I want 21 more, but the number is 12. We cannot make partitions in 12 and make it 29. So one invalid case is when my target is less than our number, not number 0. This is one case. And when my number is less than my target, then these are two what, these are invalid cases where we will invalid case. And what is the valid case is when my num gets equal to target, then. Okay, and to do this partitions, okay, as we see our constraint in this, okay, the number is less than n is less than or equal to 1000. So we n is less than or equal to 1000, so the maximum number which we have to make equal will be what, 1000. Here it was 36 and we have to make it 1000. That means we can do like, only we will check using 10, like cut here, here and here. Okay, so let's say my maximum number 1000. Okay, this is my 1000 number into 1000. How much I'll get? 60. 1 2 3 4 5 6. But I cannot make partition here, not here, right? Why? Because it will be 10,000 and we, of course, we cannot make 10,000. What I'm saying is uh, like I cannot make partition. Cannot make means I don't need to use, like, so here what we did is we did partition here, here and here in the first time. And let's say if we have 129 and if we are doing partition here, here, and if we do again, it will get 0 only. Okay, but here in this case we'll not get 0, we'll get 10 and 100, which are, of course, obviously these are the invalid cases because we will get the less number than the 1000. So we will be doing only with this 10, 100 and 1000. Okay, what I'm talking about you will get to know while coding. Okay, so what I'm saying is, let's say we will write a code. I'll explain. This will be our sum int, and for int from I is equal to 1 to I less than or equal to n I plus plus. First let's find the square. Okay, square is equal to I into I, and I'll write is punishable. I'll write this method where we will passing the square and our I, which will be our target. Okay, if it is okay, then sum plus equal to, we have to add the square. Okay, and at the end we have to return this sum. Now let's write this method. Okay, we are going to make use of recursion. Okay, as you can see here, we have to do the cuts again, cuts again, cuts. So we will be using the recursion. So what we will do, public, it will return what, boolean is punishable where int num and int target. In the previous example, the target was 36 and num was 1296. Okay, so what are the invalid cases? If my target is less than 0, or if my num is less than target, then I can say false. Okay, that is this partition cannot, like, can't be included in our this. I mean, this numbers can't be included. If my okay, if my target is equal to num, so what I can say, this is a valid, so return true. So we got what, return true. That means we can add this, include this in our punishment number. Now the main thing is return what, three things as I explained. Same we will use the recursion, and here what we will do, our num divided by 10 and target minus num percent 10. Okay, or as this is num divided by 10, okay, if I do this divided by 10, I'll get 196. Sorry, 129. I'll get 129. And if I do percent 10, I'll get 6. So I got this two. Okay, again I sent this in the next iteration. Okay, so here now if I do the percent 100, I'll get 96, divided by 100, I'll get 12. So similarly for 1000, and as I discussed, we will be using only this is punishable num divided by 100 target minus num percent 100, or is punishable num divided by 1000 comma target minus num percent 1000. Okay, so in this way these are the three different cases. Okay, so here, okay, return, yeah, here return false, right? Let's run this. You can say accepted. So here what we did, uh, we had make use of, we did make use of this recursion concept, where, so this is a simple example, 1296. For like this, we'll get this zero, this zero, this zero, and at the end we are going to get this 1000 only. Okay, so we cannot have more than this, is our maximum square. Okay, so that is why we are going to use this only thing, and for again these are the invalid cases and all. Okay, the let's submit this solution. Okay, here you can see accepted, but let me check once again. Yeah, and I'll write target equal to this is punishable, we did like this, and yeah, the square we did some. Let let's submit this again. So yeah, you can see. So just a small change. So thank you so much for watching this video. If you feel this video is helpful to you, please like this video and subscribe my channel. Stay updated for more such Leetcode daily challenge questions and different concepts. Thank you so much.